Hello, class.
Morning.
Good morning. How y'all doing? All right. Anybody with any questions so far with the assignments, tests, etc.? Questions? Hello?
I don't have any.
Okay. All right. Anybody else? Okay, we kind of started with chapter 10. I'm in chapter 10. Chapter 8. Let's look at our notes. Let me share my screen. All right, then we'll get to the notes. I got them in 93. All right. Okay. All right. So now this chapter deals with sorting and searching. And I kind of went through the assignment right after the meeting we had on the last class period. So let's look at our notes. Our notes that we have on sorting and searching. All right. And let me get to that chapter. Okay. Let's see. All right, here we go. So this is chapter 8. So now searching and sorting, and we're going to be doing this with using arrays. All right. So and then normally I use I don't normally go through here. I normally use my SYL site.
Your website saying that we can't send the roll at this time.
Okay, I'm tell you what you do. Yeah, because I think the same thing happened last class period after the meeting. What am I have to do with that? Cut this off. Okay. Okay. This is the website. Well, no, I can't. I'll tell you what, just in the chat, just type your name in the chat, your first and last name, and I'll add it for today. I forgot to go back and check that out. So in the chat, just go ahead on and put your name in the chat, and then I'll view the chat before I log out and add you to the class. Okay. So no, what I'm doing. All right. So now let's look at chapter 8, searching and sorting arrays. Okay. So now, okay, a search algorithm. Okay, what that is what we're going to be doing. We're going to use some algorithms to search for a particular value or whatnot in an array, a list of a content of information. All right. So a search algorithm is a method of locating a specific item in a larger collection of data. So it's kind of like if you have a stack of papers on the teacher's desk, and the teacher says, "Well, find me your paper." Now, there's many different ways you can go about doing it, depending on the way you think. Some people might start at the beginning and go page by assignment by assignment by assignment from the top down. Some may go from the back up, you know, the last one coming forward. Some may start in the middle. You know, it just depends on the way in which your mind thinks, and you feel, I guess, the more efficient way for you, you know, at that time. So it's very common for programs not to store and process data. Well, common for programs not only to store the data, you know, but also process data stored in arrays. And if you really look at the way computers are used in society, many times the computers are manipulating, or as it says, processing data that's already where in the system. Okay, so and give you an example, when you go to the financial aid office, and then, you know, the first question they may ask you, well, what is your L number? So what happens then? Now they type in a value, and then that value has to be searched against some file to see if what that L number exists. You know, you go to the say you going to the bank. When you go to the bank, they may ask you want to either deposit or either withdraw money. They'll ask you, what's your account number? So now they have to what? Type in that number, search for that account. So see, computers are working most oftentimes by processing data that what is already there. But it also allows you, a system should allow you to add data, update data, and maybe even what? Delete data. All right. So we will discuss two search algorithms. All right. And we'll look at the pseudocode of that algorithm, and we're going to look at the actual code of that algorithm. All right. So a linear search. It tells us a linear search is just a simple algorithm. All right. Sometimes called a sequential search. Now, who could give me an example of a sequential search? Anybody? All right, as it refers to a cassette tape, what's a sequential search? If I had a cassette tape and I had, say, 5 songs or 10 songs on the tape, and I'm trying to get to song number 7.
Fast forwarding.
Right, I have to fast forward past number 1, past number 2, past number 3, past number 4, past number 5, past number 6, then get to 7. So you understand, that's a sequential search. I have to go through each and every sequence to get to that particular mark. That's sequential. It's in that order. I got to follow one after the next, after the next, after the next, after the next. So it says with a sequential search, it uses a loop to sequentially step through an array. All right. And you have a value. Check the first one. Is it that one? No. Check the next one. Is it that one? No. Check the next one. Is it that one? No. Check the next one. So on and on until you either find it or either search the entire array, and then what? It's not found in the array. All right. So then it starts to search for the search with the first element all the way down to the end. All right. So the search process, it compares each element, starting with the first one, with the one, if you're doing it from beginning to end, with the value being searched for, and stops either when the value is found or the end of the array, either when the end of the array is encountered. When you reach the end of the array, there's no use to try to keep searching, because what? You have a certain size for the array. And so once you reach the end, you know, trying to search outside the array, you got out of bound issues. All right. If the value is being searched for is not found in the array, the algorithm should, will, and like I say, because it will or should automatically search to the end of the array, and then eventually give you a flag saying that it's not found or whatnot. And we'll look at that algorithm. So let's look at the pseudocode first. So this is a pseudocode for a linear search, right? So everybody, let's look at this algorithm, right? Now, this is not the entire program. Keep this in mind, class. This 194 class, what happens is you've taken 192. So you should understand logic and understanding pseudocode steps, you have to take or whatever. You've taken 193. 193, you went through most of the declarations of variables, if loops, for loops, functions, etc. So now you're not given, not often, entire programs. That you're given just snippets of code so that you can take it, analyze it, and then use that piece of code within your program, making sure that you may have to modify or understand what these different variable names are and are used for. Keep that in mind. So in computer science, you're just not looking at this and trying to learn it word for word. Oh, well, this was in the notes, this is like this. No, you're trying to understand the content. Everybody understand that, right? So looking at this pseudocode, this is a part of a search algorithm or search pseudocode that is a part of, could be a function or it could be in the actual main program. But normally I would tell you put this in a function. So if you know you're putting it in a function, you may have to pass some values. If you read in the value that you're searching for in the main function, you know that you would have to pass that value to that search function. If you had the array, the information read into the array in like a get function, and this was the search function, then you would have to pass that array to that search function in order for you to manipulate the array as you need to. So stuff like that you're gonna have to kind of understand. So let's look at this algorithm, all right? The pseudocode. It says set found to false. So what we're doing here is once we fall into this particular code, we don't know if we found if we're gonna find the actual value in our array. So we're gonna say, oh, it's not found because we don't know if it's found or not. So we setting a Boolean flag to found to false. So so found could equal to true or false. Now, then we setting position. Now, position is just a variable that represents the array position. All right. Now, is -1 an array position in the array? Class, would -1 be an array position?
Negative starts at 0.
Right, so it would not be. So the -1 is used to signify if we set position to -1 and we go through our code and we return -1 back to our calling function, we know that we did not what?
Find it or perform the search.
Right, we did not find the record of that particular value in that particular element. You got what I'm saying? So that's what position represents. It's going to represent the element in which you either found or did not find the value. Okay, everybody got that? So, but we're going to go down and we'll look at the return in a little while and this here. So what happens is we set position to -1. So we set it to something outside the range of our loop so that we say, okay, when I return back to my main function, I could check to see if it's -1 or if it's less than 0, I know I didn't find it. If it's 0 or greater, then I want to use whatever value it is to output that content. So it says now we set an index to 0. So now index would be our what? going to be our increments, right? Going to be like our counter of going through a processing through our loop. So what? Lists of 0, lists of 1, lists of 2, lists of 3, lists of 4, lists of 5, all the way till the max size of the array. You understand? So that's why I say you got a pseudocode, but you got to understand what these variables represent. You can't just take code and copy it, and you're like, Mr. Vester, my code, I don't know what's going on. You say this supposed to work, but if you're not using index inside your loop, then index will not work, all right? Because what? Index here should be what? A subscripted variable used to find the position of the array that has the content. So look, then we done set found to false, we set our position to -1, and we set index, which is going to be our subscript position that we incrementing by, to 0. Now here is a loop, all right? This while loop will start here and end down here. We have an if that starts here and ends here. So all this is our while loop, all right? Well, our while loop will end here. So now, before the return. So let's see, while found, which is this, is false. So, okay, we haven't found the record we're looking for, and index is less than the number of elements. So two conditions has to be true before I fall into this loop. Found has to be false. Okay, I didn't find the record, but I'm not to the end of searching. So if found is false, like say the paper's on the desk. If I'm looking for my name, I pick up the first one. Did I find it? No, find is false. All right, so that's sub-0. I put it to the side, I increment my index, and then I check to see if found is if it's found. No, it's not found. So found's gonna stay false. Then increment my index, go through it again. So what happens is, if I was gonna do this while found is false and index not equal or less than, or while index is less than the number of elements. It says if list, now what is list? List is the name of the what? Looking at this, list is would be the name of the what? The array, huh?
Is it the array?
Right, it will be the name of the array that has the values we searching. You understand? So it could be called whatever, age sub 0. If I'm looking for a particular age and I have an array of ages, if age is equal to that subscript value sub 0, if it's equal, that value is in that array position. Hey, if it's not, going to the next one, age sub 1, age sub 2, on and on and on. So list is not anything that's concrete. List is just an array name. Everybody got that? So if the array name, which is called list, sub whatever the index, we started at what? 0, is equal to the search value. If we go through this loop one time, what did that signify, class? And if we go through this loop one time and it is equal to the search value, what does that mean?
It's in the first.
Correct. The first time we checked, which was the index of 0, the first one we checked, we found the value. So that's what that would mean. So if it's found the first time, it's going to change found to equal to true, which now you won't be able to fall back in this loop the next time. But there's also going to change position, assign position to equal to the index, which is the first one, which would be 0, and it'll overwrite -1 with 0. All right. Now it's going to add 1 to index, but that doesn't matter. And then it kicks out, because once we get back here, now what? Found is equal to true. So that's going to be a false, but then index is still less. That's true. But false and true yields what?
False.
False. And so it's going to kick out the loop. It's going to return the position of the array. So we'll return the index back to the calling program, and now we can print out a sub position. You understand what I'm saying? Or whatever that position of value is. Everybody got that?
Yes, sir.
Anybody got any questions about this algorithm? So we searching, we setting values, then we creating a while loop, and then within that while loop, we checking to see if we find the value in the first position. If not, checking the second position. If not, the third position. On and on and on till we get to the max size of the array. If it's found anywhere inside the array, it's going to change found to equal true, and it's going to change position to equal to the index value, and then it's going to return, get out the loop and return the position that we found it in. All right? And if not, it's going to return what? The -1, which would mean what? It was not found in that list, and we sequentially search through it. Okay? Now, this is the actual code. Now, when I say actual, this is the code based on pretty much just algorithm. You might write algorithm where you using something here called mileage. So what I'm saying, you wouldn't have mileage here in the program. You understand? Where you have lists, it would probably be mileage. You got what I'm saying? So you got to be able to correlate the two, because otherwise you'd be like, man, well, what is this used for? I just use it in the program. I don't know why it worked or why it's not working or whatever. So you got to understand, this is an array. Whatever that array name is, we search it in that one array to find out if that value is, found. So let's look at this this code here. Now this is the same code for this algorithm here, this pseudocode. All right. So what happens here? If you look at the top, this is what put in a what? What this tells us? It's in a what?
Function.
It's in a function. And see, and the thing is, you got to recognize that, because when on some people assignments, they wrote the program, boom, 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 boom. But and some of them did it with the vectors, some of them did it with the other program. If I say using a function, automatically you know that what? If I say get the whatever from the data file using a function, you know you're gonna have to have a function header and logic to what? Retrieve data from a data file. You won't have it all in the main. And when you write the code that way, I'm looking at it and I'm saying, and it's unfair to students who take the time to write it the way I ask it. So that's why I take as much points off as I do, because it's not fair for me to give you, how would I say it? A kind of satisfactory grade on turning in an assignment that you didn't take the time or care about doing it the way the instructor asked you to do it, which entails some extra steps, and sometimes it may take more frustration. But you're gonna say, well, I'm gonna write it this easy way. He's gonna give me at least half or whatever. No, the program is wrong, But some people try to do that. Oh, I could write it this way, so I'll just do it this way and get half the point. No, you're not gonna get half the point, because you didn't do it the way I asked you to do it. Now, the program run, yes, it may run, but it's not designed or set up the way I asked you to set it up. So please read the instruction, follow what I asked you to do. If I say I want a function to do this, do it. If I say I need a function to do it, because I will take off. And those who write it using functions know, hey, sometimes they run into issues where, I need to declare whatever. Oh, once I declare, now if you change the name, I need to do whatever. Oh, I missed my double brackets. Oh, because it's an array. So you're conditioning yourself to learn how to code. But if you're just writing code all one function and doing it whatever, yeah, it'll run, but it's not as efficient, for modifying it and doing other stuff with. So make sure like I said, if I ask for functions, because this all the assignments gonna be function, right? Without with fun, except when we get to character chapter, you know, because you're gonna be manipulating the position. So I don't ask you to do it there, but every other program, function. Now, so if we look at this, int, search list, then we got our arguments, int list. List is a what? An array. Why we know that? Because we have curly braces around it. All right, I mean, at the end of it. What's the name of the array that we're going to use here? List. What's the name of the array in the main or the calling function? We don't really know, correct? Everybody understand that? We don't really know what the function, what the array name is in the function in the calling function, because we can change the name of the function when we using it in our in this particular function. Right? We could use the same name, but we don't have to. Now, look at this, int num elements. Looking at this and just taking a guess, number elements would be the size of your array. All right? That constant value that you use for your size declarator. You got what I'm saying? Now, looking at this int value would be the actual value that you typed in, but now you passing it to the to that function so you can manipulate the array. All right, but let's look back at the beginning. We have int here, and this is search list. Search list says that this is what of the function.
Is it the name of the function?
The name of the function. We got to know that. We can't be right. Well, the book said list this that. No, when I give you instruction for your program, I tell you to use different names, underscore, whatever. You understand what I'm saying? So you got to be able to put the two together and say, well, in the book, this example shows give a name of search list. That's the name of the search function. But Mr. Sylvester want to call the function his search function, and I'm just saying stuff right now. Search underscore my first initial, last initial. So what? Search list would be replaced with the name that I asked you to use. So stuff like that you got to pay attention to. But look at this first part. Most of the programs we wrote before, we had what? Void at the beginning, correct?
Right.
At the beginning. Now we got a data type. This means that we're going to be returning a what type value?
Int value.
Int value back to the calling function. Everybody understand that? So we're going to process this whole, all this code here to get a value that we're going to return back to a function. And in this program, or this particular code, all we're doing is trying to get a location or a position of the array, so which is an int value, so that we can return it back to the calling function, and then we'll be able to use that value as the subscript, to print the contents. Everybody got that? And then if it's a -1, we're gonna what? Not found. We're gonna print not found. So let's go through this logic, and I just had to tell you that. So this is the function header, and this is the three arguments: the array, the size of the array, and the value that we're searching for. Int index equals 0. Remember, index gonna go from 0 to the size of the array, depending if it's found. If it's not found. Int position equal -1. We set in position a -1 until we find the subscript where the value we're looking for. Then we're setting a bool value, a Boolean value, found to equal false, and it won't change to true until we find the value in one of the elements that we're searching. Okay? So now, look at this while loop. So it says while index is less than, now, if you look at this, it's kind of reversed. This say while found is false and index less than element. And they just kind of reversed it. While index is less than element and not found. Not found is just the same as saying what found is false, because not found is like the negative side, negative. So not found. Now, the thing is, this side and this side must still be true. So whether I put this one first, found first, or the index less than element first, it does not matter. You understand? If both of them has to be true in order for me to fall into the loop. So it didn't matter which one I put first. They both still has to be true before I fall into this loop. Now, if they both are true, if index is less than elements, num elements, and normally the first time through, what? If it's zero, the size of an array can't be zero, so we know we're gonna fall into this loop. Well, not necessarily. Well, we will, and found is set to false, so at least we're gonna hit it one time. So we're gonna fall in here. It's gonna say if list sub index, which is our array name, sub 0, and look, class, some of y'all might have this issue here. See this double equal? Very important. And I know some people gonna have issues. Well, Mr. Professor, I ran the program, I copied it just like it was in the notes, and it's not working. But when you just use one equal, what you doing, class?
You're assigning it to that.
You're assigning the value to list, which makes it true. Which says, okay, store that value into index of list. You're not comparing it, you're just storing it there. You got what I'm saying? So now you're making them both what? Equal. All right. So you got to be careful. Now, so it's asking if the index value sub 0 is equal to the value we typed in earlier. All right, and like I said, that would be from the call function. If they are equal, then we change and found to be true, so that we won't fall back in this loop, and we change in the position to whatever index we are on at the time. Because look here, we increment index. If we took this and put this outside of here, then we would never get the right index. So it's done in here. Index is incremented, but it doesn't really matter because we done found it, we done set our position, and then we get out here and it come back up here and says, while index is less than num element, yes it is. If not found, but if we'd have found it, it's gonna say, it's true, kick out, and return the position the value of position back to the calling function. Questions? Anybody with questions? Hello?
No, sir.
No questions, sir.
All right, okay. So now, just a little tidbits on the linear search. It's a simple algorithm. Like I said, you can write it. It's inefficient though in that if you have a large database or either a large file, if you had like 10, 20, 30 elements to check going from the first one to the last one, it wouldn't be no problem. But if you had like 1 million to check and the value is not found in that the million elements, what'll happen? It has to go from 0 to 1 million, checking each one just for you to tell you it's not found, correct? So with small databases, this simple algorithm, hey, it's fine, no problem. But otherwise, the disadvantage is when you have larger records to search through, all right? It's easy to understand, and there's no special requirements on the data. Now, what does that mean? That means whether the data is sorted or not, you searching from the first one to the last one. So you will what? Check everything to see if it's there and no problem. Now, so I'll read through this. If an array being searched contains 20,000 elements and the value is in the last element of the, last element, the algorithm has to what? Search the entire array just to get to that last one, all right? Which takes time, all right? on average, okay, an item is just as likely to be found at the beginning, all right, of an array or near the end, all right? So what they do, they take an average. So typically, for an array of int items, the linear search will locate the items in n divided by 2. And that's just on average, you know? Like if I have 10 different searches, and I'm searching 10 different, I would say, arrays, and I call one to search, and the element might be found in the very first one. So bam, it's done. Then another one I might find it at the very end. Another one I find it in the middle. So on average, they just saying that out of those 10 times I'm doing these searches, it'll be n divided by 2 on average, you know. So it's somewhat good, but it's not efficient enough to say use for large data. So if the array has 50,000 elements, the linear search will make a comparison with 25,000 items on average, though, okay, on them in a typical case. Now, this assumes, of course, that what? We at least find the element. Because if we have to search all these different arrays and we never find it, we're just wasting time going through the whole thing from 0 to 50. 50,000, 0 to 50,000, 0 to 50,000, 0 to 50,000, and never finding what we need, which taking up time. All right. So if not found in the array, you will be searching each element from start to finish, and not finding anything. So n divided by 2 is the average number of comparisons, where n would be the maximum number of comparisons. All right. Now, now there's another type search. We talked about the linear search, where it search what? Each element from start to finish. There's another type search called the binary search. The binary search, what it does, it takes an array and it splits it in half. Well, I'm gonna just explain to you what it does, then I'll tell you requirements. It takes an array and split it in half, and then decide whether or not it has to just process the first half or process the second half. If it says, okay, where I'm at in the middle, the value is that value, I found it. If it's less than, if the value I'm looking for is less than that middle value, I have to search the first part. If it's greater, I'll have to check the second part. But I've done what? I've just cut my search down in half. Now, there's one requirement to a binary search, because if I have an array, all right, of numbers and they're not sorted, and I cut them in half, and the value 1 is in the upper part, maybe the last element, and I'm looking for the value 1, I cut it in half, and I hit the number 5. Is 5 greater than 1? No, but then now I'm gonna check this part of it, but 1 is stuck on this other side. So the thing is, in order for your binary search to work, you have to sort your data. All right, the data must be sorted before it can be you can perform a binary search on it. So it tells us that the binary search is a clever algorithm, all right, that is much more efficient than the linear search. All right, its only requirement is that the values in the array be sorted in order. Period. That's all. But you have to do that, and we're going to talk about those algorithms after we talk about this. So instead of testing the array first element, this algorithm starts with elements in the middle, okay? And then if the element happens to contain the desired value, then the search is over. But if not, otherwise, it have to choose whether if it's less than, choose the less side. If it's greater than, choose the greater side, and then continue to keep breaking it down till it get to the last one, and then it's either found or not found, which would allow you to cut your processes down considerably. So it tells us cut it in half. If you find the desired value, you're finished. Otherwise, the value on the middle element is either greater than or less than the value being searched, because remember, it's already in order, sorted in order. If greater than, all right, and in the list, the value will be found somewhere in the last half of the array. If less than, and again, in the list, the value will be found in the lower or the first half of the list, of the array, all right? In either case, half of the array has been eliminated automatically, all right? So take again, we have 5,000 elements, all right? Or 50,000 elements. We sort them, and then we what? Split it in half, and then we say, okay, now is that the value we're looking for? No. Is it less than? Now we're only dealing with 25,000 records, right? And then on, and then 25 cut in half. And then if it's found, okay, we finish. If not, higher, lower. So it keep going on and on and on till it eliminates, do the elimination process. So looking at this example here, it says, if the desired value is not found in the middle element, the procedure is repeated for the half of the array that potentially contains the value. Okay, for instance, if the last half of the array to be searched is to be searched, the algorithm immediately tests its middle element. If the desired value isn't found, the search is narrowed to a quarter of the array, to the quarter of the array that resides before or after the element. This procedure continues. The value search until found or there is no more elements to test. So if we look down here, searching for 85, the list got 17 elements. So the list cuts it in half. Then it checks what? Well, first of all, they are sorted. You got to remember, if you're doing this binary search, it has to be sorted. So we see, looking at the numbers, they are what? They are sorted. So now we take what? Cut it in half. Is 83 greater than or less than the 63 is less than. So now you're going with this side, you cut it in half. All right, is 80, was this 81? Is 83 less than or greater than 81? It's greater than. So now you cut it in half to here, and then it's less than until you actually find the value. So what happens is you chopping it down half, quarter, and then eventually you get finding or not finding the value. Now, again, here is the algorithm. Class, you will have a program that will use both of the codes, you know, regardless of what programs you write. Two programs, one gonna use one search and one sort, well, one sort and one search. Then you're gonna use the other sort and the other search. So you're using both of them. So now let's look at this one. A little more complex, but same, you know, better results. So it tells us, again, looking at this, int, and then what? This is the name of the function, binary search, all right? But then what? Int array, okay, so this is the array that has the content that we processing, called array, and it's an integer array. Int num elements, remember the size of the array, we're passing that, the size declarator, and then int value. So that's the value. So basically, both of them are passing the same exact values when you're creating the function. All right. Well, this is just a pseudocode, I think. Yeah. No. Well, I missed the pseudocode, right, class?
Yes, sir.
Yeah. Yeah, I missed the pseudocode. All right. So y'all want me to go over pseudocode? Or want me to just continue with the algorithm, with the actual code? But the pseudocode might help, or it might confuse you. I'll continue with the algorithm since I started. Okay, and you know, you could always go back and look at the pseudocode to see what's what. All right, on the pseudocode. So int first equals 0. So now what you're doing, you're setting the value, all right, or your position to 0, all right? First array element. So you're setting that to 0. Then the last array value. Now, what happens here is, look what they did. Num element what?
-1.
Very important, class. When you copying code and looking at whatever, that stuff becomes very important, because what happens? You cannot try to compare, outside the boundary, because what's going to happen? You're going to be going and trying to compare the outside the boundary with another one if you try to split it in half. You understand? So you got to make sure that that's understandable. Then you got middle. All right. They created a variable called middle. All right. So you got int first, int last. All right, which is equal to this minus this. And then you got int middle. All right, middle is a variable that they're creating. And then what? Int position equal -1 again. So all these variables was declared from this int. Okay, everybody see that? All right, so you got to understand your code. Now, all of a sudden, now we got our Boolean value. Bool found is equal to false. So now, basically the same thing, but this time what? Less than or equal to what?
Last.
All right, remember last was what? Equal to what? Num elements -1. So you're not going to the very last element. You got what I'm saying? So you got to try to understand the logic. So while not found and first is less than or equal to the last. So now what happens is, long as it's not found, all right, the middle subscript gonna equal to first plus last divided by 2, all right? So now it's gonna take that, divide by 2. Then it's gonna ask if array submiddle is equal to the value. So now if I found the value, what I'm gonna do? Now I need to set the true. You're doing basically the same thing here. Setting as the previous in the sequential sorry. Setting found the true. Setting position the middle. All right. So it was found because it was found in the middle, and we overwrite position with the value. But now this is the simple algorithm that's gonna keep dividing it in half, whether it's on the high side or low side. But if it's not, else if array middle is greater than. So if the middle value is greater than the value you're looking for, right? Then now you're checking the what? You're trying to check the lower side, right? Because the middle value is higher. So now you're checking the lower side. And now you need to do, now you're setting your last to middle what? -1. So see what done happened now? You just reduce the size of the array that you're checking. Because remember up here, you said what? While first is less than or equal to last. And right here they set last to equal what? Middle -1. So all of a sudden, it could be, like I say, 50,000 elements. But once I divide it and check the middle, all of a sudden now it's going to either be the first half or the last half. And all I'm doing now is saying middle, if it's the lower half, is middle -1. And now I'm on that side and checking from, just those positions. And then it's going to keep reducing and reducing and reducing. So, but they say else, first gonna equal to what? Middle +1. So if it's greater, now I'm gonna go 1 plus, because it wasn't middle, right? But now I need to move my first position over to that very next element. So when I check, I'm gonna check from first still to last -1. Everybody understand that? So now it done push me into the higher part and check that part. And it's gonna continue this loop either until it's found or keep chopping it in half and getting to the end and kick out. If it does find it though, remember where it turns found equal true and position equal middle, then it's going to return middle. It's going to return the integer value middle. Okay? Any question? So that's the actual code. Now, this is the actual code. You got to be mindful, class, when you're copying code or looking at code to know what values are and why they are being used. And all of the like I say, equals, equals, the divisions, the plus ones, the minus ones, class, that can give you major headaches if you type it wrong. So look down here. This one is last. And just take, for instance, if I wrote this program and I put first right here, first equal middle minus 1, last equal middle plus 1. You know what I'm saying? I done threw my logic off. And now I'm trying to figure out what's going on. I'm not getting errors. I wrote it just like it is. Somebody that didn't write the program can come in and say, well, look, if you're comparing it to that other, here you got first, and here you got last. And you like, man, I've been looking at this and looking at this and looking at this, and I can't find it. So like I say, just take your time. You know, you got to write the code, understand your errors, and like I say, but you're going to need time. You can't try to just do it overnight, the night before or a day before. You got to work on it. Now,
Mr. Chelsea, I got a low-level question real quick.
Uh-huh.
So if you look in your while loop, the middle is declared in there. Does it have to be declared in the while loop? Like, my question is, why can't it be declared up top with first?
It is. Look here.
I mean, assigned, I think is what I'm trying to say. Like,
because you never, how would I say it? Well, because you got to do it each time you go through.
Yes, sir. Oh, gotcha. I'm tracking.
Right, because you remember,
Okay.
you're going to either be moving, each side. Right. Otherwise, you do it one time, and you know you're doing. It's like you always starting from that point on. You know?
Yes, sir. I'm copying.
Okay. All right. So, anybody else questions? All right. So, little tidbits on binary searches. The binary search obviously is much more efficient than the linear search. Every time it makes a comparison and fails to find the desired item, it eliminates at least what? Well, really half of the remaining portion of the array that must be searched. Now, to search an array of 1,000 elements would take no more than 10 comparisons. So that means 10 processes through that loop. Otherwise, if you was doing a sequential search, how many times it would take to go through the loop?
1,000.
And not finding it. I want 1,000 times, right? So 10 compared to 1,000, that's considerably low, correct? And then on average, remember it said, say on average, this would still be what? If I did a sequential search on 1,000, would be 500. So 500 as opposed to 10 still is what? A good average. And I mean, 10 would be still a good average of comparison over 500. So comparing the linear search algorithm, which would make an average of 500 comparisons, which we just talked about. So it gives you some little comparison. Powers of 2 are used to calculate the maximum number of comparisons the binary search will take on an array of any size. All right. And that's like an average, just like we did the average on the sequential search or the linear search. Now, simplifying the smallest power of 2 that is greater than or equal to the number of elements of the array. So, for example, a maximum of 16 comparisons will be made on an array of 50,000 elements. So that would be 2 to the 16, you know, which is equal to 65,536. All right. And a maximum of 20 comparisons will be made on an array of 1,000,000 elements. And that's 2 to the 20th. All right. So now, sorting. We did the 2 searches, right? So everybody, you're gonna be using those searches. All right, but one search will be used with a sort, The other search will be used with another sort. Now, I'm gonna tell you, even though you don't have to sort to perform a linear search, I'm gonna still require you to do a sort algorithm and then do the linear sort. That's just a program, and I'm just giving it to you so you can get in the habit of understanding the sort before you search. That's all it is. Now, introducing the sorting algorithm. Sorting, all right? What sorting is, all right? Sorting algorithms are used to arrange data into some order, high to low, low to high, alphabetically or whatnot, right? So oftentimes data in an array must be sorted in some order. You know, character data may be sorted alphabetically or either groups. Int data may be sorted from highest to lowest or lowest to highest, however your algorithm is written, all right? To sort data in an array, programmers must use the appropriate sorting algorithm, all right? So now, an appropriate sorting algorithm, okay? A sorting algorithm is just a technique for scanning through the array and then arranging the array content in some specific order. Here are two of the algorithms that we're gonna go through in the class: the bubble sort and the selection sort, all right? So let's look at this, the bubble sort. So we have some data here, and if you look here, we have an array here. This is an array, but there's going to be processes as we go to try to sort that array. The bubble sort, it's an easy way to arrange data in ascending or descending order, because that's all controlled by how you write the algorithm. All right, so given the following array, here we have 6 elements, and we have these numbers 7, 2, 3, 8, 9, 1 as the content of the array. The bubble sort starts by comparing the first two elements in the array. If the first element, which is sub 0, is greater than element sub 1, then we're gonna do a swap. We're gonna swap elements 1 and 0. Everybody understand that? Then what happens? It repeats this on element 1 and 2. So if you look here, it compared element 0 to element 1. Is 7 greater than 2? Yes, it is. So what? It swapped them. Then on this one, it went to 7 and 3. Is 7 greater than 3? Yes, it is. So it does what? It swaps. And it does it all the way till it gets to the end. But now, the thing is, what we had to do, we had to do a swap, correct? Everybody understand that, right? So the key here is the swap. As long as you're doing a swap in the process, you have to keep going through the loop. When the swap is set, when there's no swapping, then what? Everything should be what? In the proper order, correct? Because see what happens, see like say if eventually 7 will be placed all the way here, right? Well, no, 7 would be here, then 8 and 9 is correct. Then in the same process, then it would change 9 and 1, right? Now, what happens is when it come back to this one, well, this would be, it won't no swapping here when I check 0 and 1. This one here, no swapping. But then I check this and this, it's gonna swap, right? So it's gonna, no, it won't swap, my fault. What I'm saying, it won't swap. Then it, 1 would be here, then it'll swap 1 with 8. So see how long it's taken in order for it to get to that point? So what happens here, it says, the next element 2 and 3 is compared all the way down. These elements are already in the proper order, all right, which would be the 2 and the 3, all right? Because element 2 is less than 3, so there's no changes that to take place. As the cycle continues, 3 and 4 is compared. Once again, there's no change. But, okay, well, when element 4 and 5 is compared, however, an exchange must take place because element 4, all right, is greater than element 5. All right. So you see how this was changed. All right. That 9 had to be changed in that one process. All right. Now, at this point, the entire array was scanned. Everybody understand that? So it's going to take 2 by 2, go by 2s, and wherever it sees that the first one is less than is greater than the second one, it's going to do a swap. And as long as I do a swap, I got to go back and run it through again. And whenever I run through my loop, checking the first and second one all the way to the end, and there's no swap, then I know that my list is what? In ascending order. Anybody understand what's happening? Right?
Yes, sir.
All right. So the first time through, in a sense, if we just looking at this, all right, the first time through, it checked 7 and 2. It's going to do what? It's going to swap 2 with 7, right? It's going to put 2 here, put 7 here. Then it's going to check 7 with 3. What it's going to do? It's going to swap 7 and 3. So 2 is here, 3 is here, 7 is here. Then it's going to compare 7 with 8. No change, right? Because 7 is less than 8. Then it's going to check 8 with 9. No change because 8 is less than 9. But then it's going to check 9 with 1, and it's going to swap 9 and 1 and put 1 here. So we're going to end up with 2, 3, 7, 8, 1, and 9. We did swapping, right? So now we got to go back and start all over and do the swap. So what? That 1 is right here. How many processes? Well, how many times? How many processes is it going to take for that 1 to get from here to here? Entire processes from start to finish. So 1 is going to move it here. The next time is going to move it here. The next time is going to move the 1 I'm talking about. Going to move it here. The next time is going to move the 1 here. And then the next time is going to move the 1 here. So being that the 1 is in the last element, it's going to have to do the entire swap 1, 2, 3, 4, 5 times. Everybody see that? Just to get the 1 in the first position.
Right.
Right. So everybody understands. So that's why it's an algorithm, but at the same time, it's not an efficient algorithm. But it'll work. It will work. All right. So let's look at the pseudocode. So look at this. Now what they did, they don't have an if, they don't have a while, they have a do. That means no matter what, I want you to perform it. So what happens is if I have a list, it could be already sorted, correct? So I'm gonna say, just go ahead on and check it. Just do this. If it's sorted already, then continue. I'm not gonna set no flags to fall into something and check it and then continue. I'm gonna just say, okay, go ahead on and do the check. If everything is straight, hey, just continue on with the program. I know that my algorithm for my bubble sort will work. Well, not my sort. I mean this here binary search will work. Because I've sorted my data. All right. So now the pseudocode, and notice here we have another flag called what? Swap flag, right? So they setting swap flag, the swap flag to false. So as long as what? The swap flag is false and never changed to true, that means we didn't do any swapping. So what? Our array list is already in what? Ascending order, right? But if we do any swapping, all right, we have to set our swap flag to true, which going to allow us to have to come back and do the swapping. So while any element have swapped, so this is while swap is true. So as long as swap is true, what we got to do? We got to perform all of these steps. So as long as I did a swap, as long as I have to move a number over, I got to do my swap. So it says, okay, set the swap to false, okay? Then we're going to go on through because we thinking now that, okay, I have a list. I'm going to take it as if it's already sorted. But then I'm going to go through the algorithm just to make sure. And if it's set the swap to true, then I know it's not sorted. So it says for count is set to each subscript in the array from 0 through the next to the last subscript. Now, what's the next to the last subscript, class? If say my max subscript was my subscript for my size declarator was declared as max. What is my next to the last subscript?
-1 from max.
Max -1, right? So you understand? So you got to keep all that in mind. They're giving you pseudocode, but you got to keep that in mind. All right? Because if you can't go to the last one, you have one less than the last one. Because I can't swap the last one outside the boundary of the array, right? So when I swap the this one to the next to the last one, I'm finished. All right. So now it says if the array sub count is greater than the array sub count plus 1. All it's saying is if an array sub 0 is greater than array sub 1. That's the first time through. And then it say what? Swap the contents of array sub count and array count plus 1. Class, but there's a procedure to do that. They got this one line here, but this line here is telling you to do and I ain't gonna say a whole lot, but it's telling you to create pretty much a temporary value. You're gonna put the value of count plus 1, count into temp, count plus 1 into count, and then move the temp value into count plus 1. Oh, and I'm just talking about the subscript, but array sub count. All right. So the value that's here and the value that's here, this one, array sub count will be putting a temporary value. Then array sub count plus 1 will be put into array sub count. And then the temp value will be put into array sub count plus 1. And you've just what? You've just swapped the values. Remember, we kind of talked about that on last time. And what happens? This will continue as long as there's a swap. It's just going to continue because what? Depending on the size of our array, if it's like I say 1 million, and the number 1 is all the way at the very first element, we gonna have to pretty much do it what? 1 million times just to get it, or 1 million times -1 just to get it all the way in the first position, provided that our numbers are different numbers. All right. Now, this is an actual program, but this is the code right here. This is the code to do the sorting algorithm, sorting it in ascending order. So look here. Let's see where our function here. The void, and we have what? Sort array. So that's the name of the array. Int array, and then the what? The array size. All right. Because what? We're not entering in the sort algorithm. You're not searching for a value. So there's no value being inputted to search for in the sort algorithm. We're just taking what we have and trying to organize it. So that's why we went from what? 3 arguments now to 2. We don't have a value that we're searching for. We have our array, and then we have our array size. All right. Now, again, I want to tell you, I want to stress. Notice, this is sort array, and what? It introducing an int array called ARR. But if we look at sort array, what is passing? Values, which is what? Int array. So what? Values is used in the main function, but values is being passed into what? ARR. So whatever's in the values function, the element, will be passed into ARR. So ARR going to take on all the values of values of the value, well, all the values of the value function, right? So you gotta be able to understand that what's going on with the code. But so let's just look at this code. So ARR, which is the values array, all right, is stored in here and our size declarator. Because if we look at here, wherever size is, where's our size? Size should be
Set
somewhere.
values.
Yeah, I see that. Where? Okay, 6. Oh yeah, no. Yeah, right next to values. What they did. Now this is a dinosaur way of writing code, but they did it. Normally you would want to create a constant value and, like I say, pass that variable. You know, but this is valid. They passing a 6 into size. Okay, that will work. But like I say, look here. If you start changing your array to like say change it to 10 or whatever, you know you'd have to change this, but then you'd have to change everywhere you have this 6, you'd have to change that if you wanted to process what? The entire array. So I'm just trying to tell you that would be a more efficient way to write your code. All right. Now, so we have our values array, all right, and then we have the number 6 being passed in the size. Now, a Boolean value called swap. So we created a bool value called swap, and we created a what? A temp. Remember we talked about a temp variable? This temp variable going to be used in our swap. Everybody got that? So when we gonna swap, when we find that the first subscript is less than the second one, we have to do a swap. And in order for us to do a swap, we can't just say array sub 0 is equal to array sub 1, because what happens? I'm overriding array sub 0 with array sub 1, but I've just lost the value that was in array sub 0. So I have to kind of put it in a temporary value so I can pull it back down and put it into that array sub 1 position. So we doing it. It's setting swap to equal false, saying, okay, I think my array is already sorted, but just for safekeeping, we're gonna check it. So now we start for int count equals 0, count less than size, which is what? The size of the array minus 1. Beware of that, minus 1, count plus plus.
Is that
Now
to
look-
account? Is that to the -1? Is that first to account for the 0?
No, that's the account for this. Once I compare this with this, right?
Yes, sir.
So I'm comparing what? Array sub, what? Let's say we call this, my fault, about to sneak. If I call this numbers, if I compare, excuse me, if I'm comparing numbers sub 4 with numbers sub 5, right? And I do a swap, correct?
Yes, sir.
Do I need to do another compare?
No.
Right, because if I try to do a number sub 5 to compare it to something else, then it's gonna give me, I'm gonna be out of bounds. You understand? So that's why I say right. So that's why I go up to minus 1. Once I do this to this, I'm finished. You know what I'm saying?
Y'all come tracking now. Yes, sir.
Right. So you don't want to go beyond that. All right. All right. So now, so it tells us if the count here is greater than count plus 1, all right, it's gonna do what? A swap. But see, like I said, we went up to minus size, but then we go into count plus 1. So that takes us to that last one. If we ever get to the last one, well, we're gonna take us to the last one, right? So if array, which is the value, sub count, sub 0, is the first time through, is greater than array sub count plus 1, which we had here. If this is greater than this, then we're gonna do a swap. But you can't just do a swap. Look at it. What you gotta do? I gotta take whatever's in this location of the array element and store it into temp. So array sub count is equal to what? What temp, excuse me, is equal to array sub count. So in our example at the top, array sub count, which is 0, is equal to what? 7, right? So it's gonna take the value of 7 and put in temp, which is it, right? Now, if I take this and copy it to here, it overwrote 7, right? With 2, but I still have 7 stored up here because what? Array sub count, which is 0, is equal to array sub count plus 1. So array sub count plus 1 is equal to 2. So what it did, it took the 7 here, it stored it in a temporary value, it took the 2 and put in the count sub 0, and then now we can take the temp value and put into count sub plus 1, the array sub count plus 1. So look here, then what? Like I say, you took array sub count plus 1, which was the 2, and put into array sub count. So we made array sub count equal 2, and then here we made array sub count plus 1, which was the second element, but sub 1, to equal to temp, which was the 7. So everybody, how would I say it? It's like, what I want to say. We can't look at it in a humanistic way. If I had Mr. Marler, if I had Mr. Marler and who else is on the thing? Someone else, say Mr. Marler and say Ms. Bradford. And in a human example, if they have 2 test papers, and I say, Mr. Marler and Ms. Bradford, you all swap test papers. What y'all gonna do? Y'all gonna just what? Hand them off to each other, right? Do an exchange, correct?
Yes, sir.
That's the humanistic way. But in the computer, it's gonna execute what? One statement at a time. You understand? So now if I said this, how would I say it? Miss Bradford and Mr. Marler, I want you all to swap papers with, how would I say it? I want you to swap test papers, but I do not want you to do it simultaneously, and I do not want any of you to have 2 papers at one time. Okay, I think that'll work. Now, so both of you all have a test paper, correct?
Yes, sir.
Now, in order to swap without any one of you having 2 test papers at one time, what you're gonna have to do?
Set both of them down in a neutral position.
Well, not both of them. You don't have to do both of them.
Well, I don't see how to get past us. I don't see how to get past having 2 at one time.
Right, but what I'm saying, if you set one down, you don't have it anymore.
Right.
So you set one down, so it's put in a temporary position, right?
Yes, sir.
Then you could pass yours to Miss Bradford, and then Miss Bradford could pick up the one off the desk or whatever.
Yes,
so
sir.
You see how you have to have that temporary location or temporary person or whatever in order for you to do a swap without having it at the same time. And that's what it is in computers. I cannot assign 2 different variables, at the same time to swap value. I have to put it in a temporary location, then copy one into the other, and then copy the temp back into the last one.
Yes, sir.
Everybody,
good example. That's a good example.
Oh, okay, all right. But because I want you to kind of understand, we look at it like I said, in human eyes, saying, well, I could just put that. No, we can't do that, But now, once that happens and there's no swaps, because see, swap is true, but then it goes back and set it to false. So as soon as everything is sorted and it goes through here and nothing is being swapped, it's set to false. Well, it's set to false, it checks, and then swap is not set to true, then it kicks out, and then everything is sorted. You don't have to pass anything back because of what? The array is passed automatically as an argument right here, and right here. So whatever's done in ARR is automatically done in what? In values. Everybody got that? So you don't have to return anything back or whatever, right? So now that sorts your data, and that's just a simple bubble sort, all right? First to the second, second to the third, third to the fourth, exact, depending on how many elements, up until the -1. You understand? The size -1. Any questions? Class, any questions? Now, this is one of the simplest bubble sorts, but it kind of gets you to understand how it works. So it says, inside the sort, well, let's keep it. I'm going to go over this, we'll go over that, then I'm going to assign whatever. This is the selection. All right, so let's see. Inside the sort, well, inside the sort array function, all right, is a loop, all right, nested inside a do loop, okay? The for loop sequences through the entire array, all right? So it goes through every one, seeing if it has to swap, comparing each element in its neighborhood and swapping them if necessary, okay? Anytime two elements are exchanged, the flag variable is set to true. So when it goes back, hey, it's true, and it's gonna continue on. Now, the for loop must be executed repeatedly until it can sequence through the entire array without doing any exchanges or swap being set to false. All right. So this is why it is nested inside a do-while loop. The do-while loop sets swaps to false and then executes the loop. If swap is set to true after the loop has finished, all right, the loop will be repeated. Anytime it's set to true or there's a swap, it will continuously perform the loop. All right. Now, so that's what's this. Well, this is for int count is 0, count less than size -1, because what? We don't want to go to the last one +1. We can't do that. Well, the last one and then a +1. So that's why. Because see, we're doing count +1 here. Because so this is count. This is size -1. So the one less size, compare that to that one. If it's a swap, we do a swap. Then we start all over again. All right, without not allowing us to go over. All right. So the variable count holds the array subscript values. All right. It starts at 0 and is incremented as long as it's less than size -1. The value of size is the number of elements, the size declarator of the array, and count stops just short of reaching the value because the following line compares each element with the one after it. So if I'm comparing the 0 with the 1, 1 with the 2, 2 with the 3, I don't want to go up until the last one because they're going to check the last one and try to check outside the boundaries. That's all it's saying. So when array subcount is the next to the last element, it will be compared to the last element to see if it has to do a swap. If the loop were allowed to increment, which I just said, count to pass size -1, the last element of the array would be compared to a value outside of the array, all right, which is simply what I just said. All right, now the selection sort, okay? Now, unlike the bubble sort is somewhat inefficient, all right, for large arrays, all right? Because items only move, what, one element at a time, really, yeah, and swap. One element, swap, one element, swap, if it has to swap. All right, the selection sort, however, usually performs fewer exchanges because it moves items immediately to their final position in the array. So if I find that this item, boom, it's gonna go straight to that location. So the selection sort procedure, the smallest value in the array is located and is moved to the 0 element. The next smallest element is located and moved to the 1 position. Then the procedure continues until it places all of them in proper order. So if let's see if they have an example. Okay, they have an example. So what it's going to do is going to say, okay, let's check this. Is this greater than that? They're going to find it. Okay, 1 is the lowest. Now, where 1 go? Bam, it goes at the beginning. Find the next lowest. Oh, it's 2. Where does it go? Boom, it goes here. So see how you're reducing the processes in which it has to iterate through the loops and the array. So this one actually finds a value, and then okay, it's going. This is my first process. It goes in the sub-0. But now remember, we still doing what? Swapping, because you can't just take the first value, the lowest value, and put here. I have to do what? Swap this out, swap this to here, move this to this, then move this to there. Everybody understand it? So there's still some swapping, even though the algorithm is a little different. If you know this, where is it? Here, all right? They're still doing some swapping, all right? Because what they're doing is array sub min is equal to array sub start, and it's putting it here. Then array where it is, array sub start is equal to array sub min. So see how you still got these values being swapped out, and then this is min value. So this was the min value. So this was like the temp value, but we moved this start into this, and then our min value into the start value here. All right, so you still got 1, 2, 3 different values. All right, but min value is in here. So this is where the swapping is being done. Now, I'm gonna hold off here because it's 11:20. But what I want to tell you is, in your assignments, and I'm gonna look at this one, and I'm gonna go back to the other one. In your assignments, notice here, this array, this is where the information is being swapped, right? In this bubble sort. In your assignment, how many? Well, we talked about it, but I'm gonna just say, in your assignment, you have name array, year array, and amount array. I think those three arrays. Now, the thing is, if I'm gonna swap or move any one of these elements in a position, like I say, when I'm doing this, if I'm moving any one of these elements, like say here, I'm gonna do right here. If I'm moving this element to here and this element to here, and that's for a numbers array, and I have a record of information, I have to make sure I do my name array the exact same time and my amount array at the exact same time. Otherwise, what? My data gonna be all screwed up. And what I mean by that is, if I find that my year has to be swapped, and these are the subscripts, I need to do a swap. Well, set a temp value for my name array, all right, which it should be string, and store that string value in a temp. Then do my swap for my string. And then if I'm doing the amount, which is a float value, I need to have a float temp value, float temp variable, and then swap that out so that all of my data can swap together. And to give you an example, how many people have ever used Microsoft Excel? And if you use Microsoft Excel, you can do a sort function. You can, it's a icon. You can click on the sort icon, but Excel kind of is smart with it. Excel will ask you, or sometime depending on what you chose, it might say something. I'm gonna open up Excel. It might say something like, "You have not chosen the entire content. Are you sure you want to just swap, just sort this information?" And let me see if I could give you an example of that. So if I have this, if I have bill 200, Tim 350, Jan 820, Mary. All right, and just say, all right, so say I have this information here, all right? Now, and I'll just format it to where you see as numbers. Okay, so, and I'm gonna make it a little bit bigger. Okay. All right, so say I have this information here, and say I clicked on this, I highlighted this, and I say, well, I want to sort this in ascending order. I can go over here, I need to move this. I could go over here and choose my sort and watch. If I sort from smaller to high, notice what it asks me. It says, Microsoft Excel found data next to your selection, okay? So it has found data next to my selection, okay? Since you have not selected the data, it will not be sorted, all right? Hold on, class, let me see something, and then hello? Hello? No. Spam or something. All right. So now, if I just go ahead on and sort it, well, let's say expand it, but if I just continue, all right, what have happened? Now, Bill has $102, which was wrong. But let me do an undo to show you. All right. This is what it originally was, and this is what it is. So my point is, if you do not swap your name and all of the different arrays that you have, then your data will be just be misrepresented. All right. So, cause look, Bill, I know Bill probably would be upset if this was the amount he had in the bank. You understand? Look at Mary. Mary got $29.10 or $2,910. Oh, what did I do? What I'm doing? Oh. All right. So what happened? Mary's amount went to Sue because I sorted in ascending order. But this is what I'm talking about. I'm gonna undo this, but then watch what happens. If I select this and I'm gonna sort it again, and this time, well, no, I'll just select it just like this so you can see it's gonna give me that same message. All right, sort it. All right, I'm gonna expand it and let it go and do all of them. Look what happens. Now what? Sue name came up and it still matched with 102. Mary name is at the bottom and it still matches with 2910. So this is what I'm trying to tell you. When you're writing this code, you're gonna have to be very, very, well, that's not it. You're gonna have to be very careful as to here when you're doing your swapping. If I'm gonna swap, when I read in my names, I'm gonna read in, say if I told you to write a program that input 10 names, 10 years, and 10 amounts. So you might have bill, whatever, an amount. Bill, the year amount, whoever the year amount. So when I swap bill to a certain position or year to a certain position, I want the name to be swapped in that same position, and I want the amount to be swapped. So you'd have, depending on the number of arrays that you may have, you're gonna have to have that many sections of swap right here to do a temp, and then do that into that, and then this into this, and temp into that, and then you're done. All right. Questions on that, class?
No, sir.
Okay. Now, what I'm gonna do, class, I'm gonna assign because I think the next part of the chapter was vectors. Yeah. We talked about vectors. That vector part, don't worry about it. Let's the program, and I'll just kind of run through them right quick and let you go. The programs, I'm gonna open them up, so you can, or I don't know if I've already opened them up, but I'll open them up and put a due date on them, and so you could get started with them. All right. All right. Okay, I should have probably stayed on the other side. On the other, what's wrong? Oh no, I haven't opened them up. So assignment 3. So assignment 3. Now it says submit your source code .cpp file. Okay, and your data file. The names of the data file. I'm giving you the names. So class, follow those instructions. All right. If your program does not execute properly, send comments along with your submission. All right. Program does not work. Because I don't want to try to be downloading and execute programs and they're not working. Wait, this is not the one, though. This is the one? Yeah, this is the program. So what it says, and you got to remember those different sort and search algorithms. For number 3, you're writing a program to read in data from a data file. You want to read in 10 records, and you want to print out the original data. It'll be done from a function. Using the bubble sort, you want to sort the data. So the thing is, they said, well, Mr. Vesta, my data was already sorted in the file. I don't care. I'm gonna have a file and my data won't be sorted. So regardless if you sort the data when you put it in, I want it to be able to sort it if it's not put in correctly. All right, using a bubble sort, okay, sort the data by year. Now see, I'm giving you a specific particular value to search by. Remember in the example that the search was list. This one's gonna be by year, right? And like I say, then prompt the user to enter the year, and then I want you to output whether or not that record was found. And look at this example. You're gonna read in 10 names, years, and tuition. Then you're gonna print out the original list. Then you're gonna print out the sorted list, sorted by the year. But notice, Ben, 1992, when I printed my sorted list, it printed the 1992 as the first one, but Ben is still associated with it, and 0 amount for tuition is associated with it also. But then what I did here is what? Prompt the user to insert a year to search for. I typed in 2011, and then it pulled up David 2011 and the correct amount. Everybody understand that? All right. Use functions to output, sort, and search, and search routines. So your output, notice here when it says print out the original data, that's a function. Now, the thing is, you can use the same print function to print out the sorted and unsorted data. You just call it when you need to call it. You print out the same, arrays, right? So you just call in the same function twice, correct? And like I said, you have a function for your bubble sort, a function for your linear search. Now, if I go back, and like I say, we got documentation, and class, what I'm gonna do for documentation, I'm gonna create a file with the heading, like I'm gonna put cover page, I'm gonna put statement of the problem, I'm gonna put source code, because man, some people putting things out of order, some people just give me whatever, and I'm like, man, the output of a data file and the actual output is not the same. Output file is an output file written to a file. It's not the output to the screen. So like I say, but we gonna have to talk on that one. But I'm gonna try to create a file so you can work with, so that, man, you'll know what goes in there, and not have my pages out of order. Cause man, it just, and or have pages or whatever. But let's look at this next one. Assignment 4. Assignment 4, basically the exact same program, but what's the difference? Selection, sort, and the binary search. So you're doing two identical programs, but the method of solving it is different. Your algorithms for your search is different. The algorithm for your sort is different. Everybody understand that?
Yes, sir.
You're still using functions. You still reading in the name, year, and tuition. All right, still doing the search. You print out the original, printing out the sorted. In class, I give you this as for a reason. This is how I want my data printed. Original data, name, and I don't be too particular on the width, but I want it looking like this. I don't want you the name or whatever. No, give me what I asked for. Original data, the column headings, the 10 names with the year and tuition. Sorted data, name heading, and then the 10 name, year, tuition. Then enter your year. It will enter year. A person will type in a year, and it will either say record found and then give me this, or record not found. Everybody got that?
Yes, sir.
All right. All right. So let me get ready for my next class. I'm gonna open up the assignments, make them do for next week, and like I say, work on them. You need to try to work on them and get them turned in. All right, and do the documentation. All right.
Got you.
All right, class. So see y'all. Anybody had any issues that I needed to deal with? Everybody turned in. Everybody type their name in the comments so I can add them to the roll. Right.
Oh, I haven't yet. Let me
do that
Oh,
for
yeah.
you too.
Okay, yeah, do that. And once you do that, I'll go ahead on and add you. So let me go ahead on and update this and put in make this available to you. Let's expand here. Okay, let's see. Edit that. Okay. Yeah, you got a doc. What is the document? Okay. What is writing getting on this screen?
I don't know. That's confusing me too.
You see that?
Yes,
Man,
sir.
it's like somebody that either hacked in or something. I don't know what's going on.
Someone's annotating.
Somebody else?
Yeah, someone's annotating. Like you guys should just draw or stuff.
Yeah, but I'm saying if they do that, why would it show without the host allowing them to? That's what I'm
Not
saying.
sure. Did you have it? That's a check mark for people to do it before.
Oh, I don't know. I can't say. Let's see something. What the date is? Today the 22nd. Oh, this is 2018. 20. All right. Okay. All right. So I'll make it do that like the 29th. And class, don't wait till the last minute to do my song.
Yes, sir.
And check it. You know, when you're going through it, make sure you check it. Okay, that's probably. Okay.
Oh yeah.
What that?
Sylvester.
And I tell y'all just work on step by step. Get your like I say, read it in, write it out. Okay, I got that part. Sort it, print it out. Got that part. You know what I'm saying? Search. So I'm saying if you do it in stages, I think you won't get so overwhelmed as to try to do all of it at one time. You know. But like I said, it's up to you. That's how you do it. Yeah. What you had, Mr. Singleton?
I wanted to ask you about the output input data file? Because I tried looking back on my external hard drive because I remember ran the program as like looking at it as notes, but somehow I ended up losing it. So I was gonna ask.
Oh, you
what
talking
was
about when you
the-
submitted it to me as the assignment?
No, mostly just the using data file that open.
Oh, in what? You talking about creating it in
Yes, sir. That and
how to
having
create it with
input and output.
visual?
Yes, sir. I'm trying to remember what chapter it was, but I couldn't find the.
No, nuh-uh. I think how to create a data file, or just how to use a data file.
Just how to use it.
Oh, that was chapter 5 in the book, I think.
Yes, sir. Okay, thank you.
Yeah.
Just wanted
If
to
not chapter 5, chapter 6, but definitely 5, from 5 to 6. Because 3 was ifs or loops. No, 3 was the if statement, and 4 was loops. And I think 5 was the end of it was like the data file. And 6 was 5 and 6 was maybe data files, I think. Yeah.
Okay.
And because 7 was array, yeah. Yeah.
All right. Okay. Thank you.
All right. But if you to create a data file, I think I have that in my how-to video. You know what I'm saying?
Yes, sir.
Huh? Oh, it is there?
It should be. I remember saving the playlist on my
Right.
task-
But
on
like down here, like the how-to,
yes,
see
sir.
down here? Yeah. And it might show up a little different on mine. Look, creating a data file in Visual Studio. Creating a file. So like I said, you always could go to my web page and look at that how-to, you know. Yeah.
Yes, sir. Thank you.
Yeah. Now, some of y'all that's in my and like I said, it might be a challenge. In my Linux class, you can try to use the G++ in that calco and run your stuff through that and see how it works. Yeah. Let me look at this chat. Let me copy this so I can have it. Oh, I don't want this. I want the chat. Why is the chat? Why is the chat? Why is my chat? Okay, here we go. There we go. So I'll just control A. Can I do that? Okay, let me get all of it. Yep. Copy. And I'll go here. Go here. 294. I'm gonna do that. Oh, no word. No word. Oh, here we go. You did my program, my assignment, Mr. Marlon. Oh, he gone. Oh, man. Nine 22. Oh. 11/22. Yeah. All right. Anybody with any other questions?
No, sir. Not for me.
All right. So I'll see y'all on next class period. Work on my assignments. Like I said, I don't know. I'm gonna see. Depending on Thursday, I got a class Thursday at 10. Depending on Thursday, and like I said, I ain't gonna guarantee it, but depending Thursday evening, maybe I got a 12 o'clock class. No, it's at 10. So yeah, depending maybe at 12 o'clock after my class, I might open up a session and we can go over some stuff. But like I said, I'll send an announcement if I'm gonna do it. All right. So
Yes,
like I
sir.
say, now, like I say, it's gonna be people who got issues with the program. If you don't start it, you don't work on it, then what? It don't need for me to have it, you know, because I would just be on there trying to do the work for you. But if you got questions, Mr. Besser, I'm working on this. I got this issue or this. Well, how do I do that? Why this? Whatever. All right. So
Yes,
come
sir.
bring something is what I'm saying. You know, do something. Don't just come there and try to grab. Oh, I'm gonna do this. Oh, he wrote that. No, come with something so we can answer your question. All right.
Yes, sir.
All right. So I'll see y'all. Let me get to my next class.
All right. Have a good day, sir.
All right, y'all have a good one.
You too.
All right. And then, well, I'll do that next. I'll do that for now.